This is a 110 battery charger, and in error I plugged it into a 220. That happens in the year 2020. So it's been sitting around for over a year, and I've decided to look into whether I can fix it. As I mentioned before, as much as you want to be careful about plugging a 110 into 220 and you don't want that to happen, you will eventually plug in a 110 into 220. This battery charger, it's really important to have a battery charger in the Philippines. They don't go around having booster cable. So what people tend to do is a vehicle with discharged battery, they remove the battery and borrow a fully charged battery and then start the car, that sort of thing. So the car is running, unplug the borrowed battery and then plug in the discharged battery. So that's kind of silly. It's actually it's silly. I mean, it can be done, but there's a risk. So those in the know that knows that buys those portable chargers, booster, that really help. I have one of those, this booster that came from Canada, of course. So always have one in your car, and a booster cable. So I'll say about whether I can fix this. When I plug it in 220, I mean, I can smell the burnt component. And you can, once it's plugged in and it's beginning to cook, there's a lot of damage. I don't know how much damage this thing is, so I'm just gonna take it apart, see what happens. Okay, the housing is disassembled. So it appears the fuse is blown, of course. Ooh, that really bad. Wonder what fuse rating it is. And the transurb or metal oxide varistor, transurb is another word for it. What it does is, if there's an over voltage, then it would protect the circuit board. Now, the transorbs come after the fuse, but if the fuse is way too large, the transorb job is to limit the 110. So for example, if it was 150 volts, it would clamp it down to 120. There's a rating for it. So, I mean, imagine double the voltage, 110 to 40, for example. It would go poof, which it did. Now, its main job, of course, is to protect the circuit board. The question then is, did it protect the circuit board? So it would clamp the voltage, or try to clamp, and then if it couldn't clamp, as it clamped the voltage, it would draw a lot of current through itself. That's why it's damaged. And then at the same time blow the fuse. So that's the job of a transorb or metal oxide varistor, MOV. So hopefully they did the job and no other component is damaged. I have to check for short. However, the MOV needs to be removed and replaced, which I don't have. Okay, the fuse looked to be 12.5 12.5 amps. And the marking on this is TVR, so TVS or TVR 10271. So I have to look at the data sheet for this one. Well, maybe I can buy it somewhere. 12.5 is a special amps fuse. I don't have 12.5 amps fuse. So, but I'm gonna test it with 10 amps if I have it, just to see if it is actually working. But I gotta check any shorts first before I plug it in. Well, it seems to be alright, although when I check how the did a little bit of reverse engineering here. So the transform is tied to the other side of the common mode choke, which doesn't make sense. Typically the transfer would be fuse and then MOVs, and then from that it protects the others, the remaining circuits. Here this is fuse, it goes to the common mode choke, and then another common mode choke. So just doesn't make sense. Well, that's quite interesting. They have two they have in series two common mode choke. This is basically to kill any type of noise, radio interference. Not to say that I agree with how they did with the MOVs, but oh well, that's how they did it. This kind of circuit board, this is 4-layer by the way. They have to go through testing for radio interference. It's not just a common electronic device. Because it's high current, it would radiate. So they felt the need to have two common mode choke in series to kill any type of RF interference. Yeah, interesting. Well, I happen to have 3.15 amps, so just for the purpose of testing the circuit, I'm going to install it into the device and then power it up. Hopefully it won't go poof. I didn't see any short between the mains, so I think it should be alright. Hopefully. Okay, its fuse is plugged in, so I'm just gonna now plug it into 110. Hopefully it won't go poof. Oh wow, that's good. Okay, then I just have to look for MOVs and or transform and 11.5 or 12.5 amps fuse. Hopefully they have it at Lazada. So I'll do another video when I get it or fix. So it'll be part 2. So lessons learned, or reminding you, no matter how much careful you are not to plug in a 110 into 220, you will. I like this charger. I was very careful not to plug it into 220. Well, it doesn't matter. I did it in a way, and then when I did plug it into 220, you know, that feeling of frustration and yeah, disgust. like like why did I plug it into 220? Well, I did because I did it. It's the way it is. You can't help it. You will plug it into 220. And don't feel bad when you do that. When 110 device go poof, don't feel bad. I tell you because you know that you will make that mistake. You will tell yourself not to plug in a 110 to 220, but you will do it eventually. So this is what happened. I wanted to use a charger. My battery was dead. Car vehicle battery was dead. I wanted to charge it, and I'm just going through the process. You plug in the device. You don't think about it. You just wanted to charge the battery. Well, poof. Um, you smell this burning scent in the air, and thought, oh, gee, it is like, how can I be so, that word, stupid? But you will, and you will feel that, like, oh well, accept it that you will plug in a 110 into 220 and then live with it. See if you can fix it. If not, if you can't fix it or get somebody to fix it, get a 220 charger. You can buy them at Lazada. They're not the same as you would if you buy them in North America, but it's a charger. I mean, who cares? As long as it charges a battery, that's the main thing.